Okay, so we're on the activity series concept, which is the middle of page 4. I'm first going to talk about the activity series of metals. The activity series of metals is listed here in the chapter handout, and it's also on the worksheet. It's on the back side of single replacement reactions, and it's up here at the top. Okay? Now, we use the activity series of metals to predict whether the metal that is by itself is more active than the metal in the compound. I'm going to say that one more time, okay? And I'm going to outline it for you. When I have a single replacement reaction where I have a metal by itself and I'm combining it with a compound that contains another metal, A and B are my metals that I've underlined, and these are bolded for you in the chapter handout. When metal A is more active than metal B in the compound, it will be further to the left in the activity series of metals. So if you look here, the most active metals are on the left, the least active are on the right, and it says that in parentheses. Okay, so the metal that it's by itself, when it is more active or further to the left in the activity series than the metal that's in the compound, then what will happen is they will trade places and the single replacement reaction will occur. So let's make a note that metal A is more active than metal B. That means this reaction will occur spontaneously, and A and B will switch places. So when they switch places, you'll kick out metal B by itself and you'll produce compound AZ. Remember, you need to list the metal first in the compound and the non-metal second, or the cation first and the anion second. Okay, so I'm going to do an example for you. It's student exercise 4A. It says aluminum foil, which is just a piece of aluminum, so I'm going to write aluminum with a little S after it. It's a solid, is added to an iron 2 sulfate solution. Okay, iron 2 sulfate is FeSO4. Remember, you have Fe plus 2, SO4 minus 2. The numbers in the charges cancel. You get FeSO4. Since it's a solution, you have to put AQ after it. So here we have aluminum metal by itself. You want to see if the aluminum metal is more active than the iron that's in the compound. So I'm going to take a look at my activity series of metals. Here you will see aluminum is further to the left than iron, which is just a few after it. So since aluminum is further to the left than iron, what's going to happen is they will switch places. And when they switch places, you will get a spontaneous reaction. So you're going to have iron kicked out by itself, and then you're going to produce an aluminum sulfate compound. Now, what might be easier for you is if you write these out in words first. So I'm going to write aluminum and iron 2 sulfate in words. Okay, I'm going to underline the iron and the aluminum because they're going to switch. And when they switch places, I kick out the iron and I get aluminum sulfate. So it looks just like this. Okay? Even though you're kicking out iron 2, you will not put a charge on the iron. Okay? You're just going to leave it as Fe. And then aluminum sulfate is Al parentheses SO4 parentheses 3. I'm going to show you the charges that I crossed to get that. Okay? Okay, now it's not balanced. You have to put a 2 in front of Al to balance the aluminum, a 3 in front of SO4, FeSO4, and a 3 in front of Fe. Okay? All right, so now you're done. And this all happened because aluminum, which is the pure metal, is more active than the Fe, the iron in the compound, and that meant that a spontaneous reaction would occur. Okay, now there is another activity series And this one is for halogens, or nonmetals, which are in group 7A. Okay, so the activity series for halogens is right here. It is also listed in your worksheet up at the top on the back page, in case you need it. Okay, now this is when you have the type 2 single replacement reactions. So remember, when you have a nonmetal by itself and you're combining it with a compound that contains another nonmetal, both of these nonmetals would have to be from group 7A, which are the halogens. Okay, so when nonmetal C, which is by itself, is more active than nonmetal E, then they will trade places and a spontaneous reaction will occur. Okay? So nonmetal C has to be more active or further to the left in the activity series of halogens than nonmetal E. They will trade places. You'll kick out E by itself and you'll produce compound DC. Now remember, D is the metal or the cation, C is the nonmetal or the anion. It must be listed second. If nonmetal C is not more active than nonmetal E, then a spontaneous reaction doesn't occur and you simply write no reaction. Okay, and you don't have to do any of it. So let me give you a example. If I give you something like chlorine and I combine it with magnesium bromide, and this example is not in your handout. Okay. Chlorine and bromine are both halogens. We're using the halogen activity series. We want to see if chlorine is more active than bromine. Chlorine would have to be further to the left than bromine in the activity series. Okay. And if you look, chlorine it's further to the left than bromine. That means chlorine and bromine will trade places. Okay. So when they trade places, I'm going to kick out bromine by itself. Bromine is highlighted on the periodic table. It is a diatomic element, so we have to write Br2. And then magnesium is going to combine with chlorine. Magnesium has a +2 charge. Chlorine has a -1 charge. I'll write that in here for you so you can see what I'm crossing. And you're going to get this, okay? And it's totally balanced. If it's easier for you, then what you do is write it out in words, underline what's going to be switching, and then write out the chemical names first before you write out the chemical formulas like this. Okay? Okay, now there is one more list of elements that will react based upon where they're located on the periodic table. This is called metals that react with water at room temperature. Okay, so this is underneath the activity series of metals. It says metals that react with water at room temperature, group 1A, 2A, and then I list them all for you. Okay, so this is also at the top of the back of the single replacement reaction worksheet. So let me give you an example. Okay, and I'm just going to title this so you know. Okay, so we're going to take a look at C. It says magnesium metal, which would be Mg, is added to water. You want to write water as HOH, just like this. Okay, now since magnesium tends to form a cation, because metals like to lose electrons, it is going to switch with the hydrogen in the water. So I'm going to write this out in words as magnesium plus hydrogen hydroxide. So the hydrogen and the magnesium, those are the ones that would switch because they both tend to form cations. Now, is magnesium in my list of metals that react with water at room temperature. So I'm looking for elements that are in group 1A and 2A, and 2A I specifically listed, in parentheses after I specifically listed lithium, sodium, potassium, and rubidium, and cesium, which are in group 1A, and then calcium, strontium, and barium, which are in group 2A. Magnesium is not in my list, therefore this would be no reaction. I can simply write no reaction and I don't have to finish it off, okay? But if magnesium was in my list of metals that react with water at room temperature, then I would have to complete the reaction and balance it. Now, in the homework, I specifically told you, like on number 11 and number 16, to check the list of metals that react with water at room temperature on those examples. Okay? Just make sure that you write the water as hydrogen hydroxide so that way you know what is switching when you're predicting your products. Okay? All right, there's one more example in your chapter handout that I'm going to do with you. It is example B. It says I have manganese metal, which is Mn, with a little s, and I'm combining it with acetic acid. Acetic acid is hydrogen attached to the acetate ion. It is an oxy acid. The ones in the charges cancel, and there you go. Okay? This is what I would do if I were you. I would write this out as manganese plus hydrogen acetate. So anytime you're doing a single replacement reaction with an acid, write the acid out as hydrogen and then whatever is attached to it, because it'll make it so much easier for you to figure out what it is that you're supposed to be switching. The manganese and the hydrogen are the ones that tend to form cations, so those are the two that I'm looking at. And you may be wondering, okay, what activity series am I looking at here? You want to look at the activity series of metals, because anytime you put a metal into an acid, you're going to compare it with this H here that is bolded. So you may want to make a little note or highlight the H and write acid underneath it. Okay? So you want to see if the metal manganese is further to the left than hydrogen in your activity series of metals. And it is. Manganese is right here after aluminum. Okay? So since it is further to the left than the hydrogen, that means that this is a spontaneous reaction. The manganese and the hydrogen will switch places. You're going to end up kicking hydrogen out by itself. Hydrogen is highlighted on the periodic table. That means it is diatomic. You write H2. And then you're going to produce manganese 2. Remember, assume that it is a +2 charge if it's a transition metal and you don't know what the charge is. It'll be manganese 2 acetate. So this is going to be like this. We're going to cross those charges, and you're going to get Mn parentheses C2 H3O2 with a little subscript 2. It's going to look like this. And then it's not balanced, so you have to put a 2 in front of the acetic acid or the hydrogen acetate, and you are done. Okay, so now you can do the back of the single replacement reaction worksheet, and I highly suggest you write everything out in words first. If it isn't written in words already, switch them and then go to the chemical formulas, but make sure you're referencing the activity series above, and you should be fine.